Hey guys. Great. What time is it? 8:03. Okay. Yeah, we'll start in a little while. Oh, this is the last class, right? Officially, anyway. Oops. Hang on. Join meeting. What do I do again? I get back in this meeting here. Anyway, yeah, I can talk while I'm doing this, right? Yeah, today we'll do more pointers, maybe, right? And then linked data structures. Wow, I can't believe the number of steps that took. Yeah, you guys should feel free to talk. By the way, I'm not going to have a class next week unless any of you, you guys get back to me, right? So if a bunch of you want to have a class, you have to decide and ask. Otherwise, yeah, no class. Yeah, in fact, if you'd like no class, let me know. Right? You can just take off. I mean, if you have any last minute questions, obviously, there are many avenues to get help. It doesn't actually have to be in class, right? But so technically, if you really only want a class, if you want to get together and talk about stuff that you may not get elsewhere, maybe computer science related stuff, but not formally part of any class that we need to teach. Good practices and what people are doing out there, and what things you can pick up, what are things, cool things you can do, and interesting ideas for summer, right? And I think I mentioned this before. Summer, you got to watch out for it. I mean, I realized much later on, that summer breaks are extremely valuable to students, because that's a time when you can actually find something that you like and basically take a break from the external world, right? And just dive into it. Forget about all these other skills that you have. Just say that for the next 2 months, which would probably have been lost to Netflix or you can still, the cool thing is you can still be on vacation, right? You can still be on vacation, you can be on a beach, but you can still be doing all this cool things, cool things, right? So you can still be coding, because even go to anywhere, right? Any beach now, they have Wi-Fi. And so you can basically just be coding all the time. And but so that's what I mean, right? So you don't have, so this is probably something that your summer plans may not interfere with your other summer plans, right? Because let's say if you wanted to take up scuba diving and even diving in summer, right? So that kind of rules out some other things, right? Or maybe if you want to do skiing, that rules out, so but this thing I think has the maximum overlap with anything else that you want to do, right? Whether you want to go skiing or you want to go scuba diving, you can always go back to your hotel room or or your VRBO place and start coding at night. So you don't have to give this up. So which means that you can still have a good time, but really focus on this while being absent. Because for all practical purposes, everybody essentially, for all practical purposes, could assume that you are on vacation for 2 months, right? You're not contactable except for emergencies. So so those are the 2 months you basically take off. This is going to be your mental vacation, as well as maybe combined with a physical vacation. Who knows, right? But this time you're going to say, I'm going to go in, pick up this new skill. Maybe I have a little bit of a running start. Maybe I have no start at all. I'm going to enter it cold. That's fine. And who knows? At the end, I might come out cold. right? So, but I have now decided upfront. See, this is the thing that I think most people will give up. I've found, at least extrapolating from my own life, right? Well, the primary reason I think that many people give up is because they have not yet reaped the reward of the end, or or they haven't gotten in. They're getting in with an expectation, right? Yeah, I think that's right. So their expectation is there, is deferred all the way to the end, and then it starts getting dimmer and dimmer, harder and harder to reach. However, I think a change in perspective, no, nothing else changes, right? Just a change in perspective helps a great deal by just looking at it as sunk cost, right? Saying that, well, these 2 months that were given to me, I basically wasted. This is what you're gonna say. This is a story you're building up. So I just wasted those 2 months. Totally, not wasted. I had a really, really good time, but that good time is not really laying a foundation for much better times downstream, right? So you can say that that's what happened. So mentally resign yourself to the fact that that's what happened, which now means that you have these 2 months and you can do whatever the hell you want. And even if you fail halfway through and you give up, you know that you can give up anytime, right? So because you've already given up, essentially you've already given up, right? But you're going forward without expectations now because you've given up. Now you can say, well, what do I lose? I've already lost everything. I don't have anything to lose. So, the best thing I can do is just keep going on, right? So it's fun to do it. So I'm just going to keep doing. And so you're not afraid to stop anytime and keep going. And I think that if you look at it that way, this summer, pick up a project in C++. I'm saying C++, it doesn't actually have to be C++, okay? It can be anything, right? May not even be computer science, but I'm just using CS as an example, which I think is really, really cool. Now, say for the next 2 months, I'm not going to worry about college admissions. I'm not going to worry about, where I'm going to end up or which, right? So I've got enough money saved up to last me for 2 months, and this is my 2-month vacation, right? And then pick up a skill for which you think that some part of CS2A has helped. Yeah, that's why I suggested. What was I suggesting? Some C++ project, right? Or a framework that uses C++, right? I think maybe those of you who are in the Java world, maybe you can say, oh, I want to do Unity and things like that, right? Like that. In C++, there's so many frameworks you can pick up, and pick one up and say, I have just, that's my vacation. And then, you'll find this is a vacation that's actually worth it, as opposed to so many vacations I've had, which were really, really fun, but they were not worth it. I don't know if that makes any sense at all. Fun is really fun, but only when it's fun. But worth is worth always. I know. That's how I look at it. All right. What time is it? All right. So someone keep talking for another 5 or 10 minutes, and then we can start coding. What we'll do is, I don't know who was coding. Rishabh was coding last class. Where's Rishabh? I saw him a few minutes ago. He just disappeared. Where's he gone? Is he got a? This must be him, right? Yeah, this is him. Yeah, maybe he stepped out. So I think he was coding last class. What we can do is someone pick up the screen. You know what? Yeah, let's not use that code. We'll start brand new, right? Yeah. So anyone can pick up the screen today, and we'll run with it. This will probably be our last coding session this quarter, right? Hey, how many of you are going to do CS2B? Planning to do? Raise your hand, right? I can't see anything in the chat window. Just raise your hand if you're planning.
I'm probably not going to do it over the summer, but I plan to do it eventually.
Yeah. No, yeah, that's what I wanted to suggest, right? Save it. Rishabh, did you raise your hand for summer or later?
I was in priority registration, so I got locked out before it can.
Yeah. All right. Yeah, don't do it in summer. Yeah, since I have a chance to talk to you guys in person, I can tell you this. Summer is really for, I don't know. I don't know why people do CS2B and CS2C in summer, right? It's like saying, you know, going to an ice cream store and saying, give me all of your flavors, and you know, and then I'm gonna just stuff it into my mouth and head right out of here. Right?
Wait, 6 weeks, right? The summer session is 6
Yeah,
weeks.
totally crazy. Yeah, I don't know. The CS2B quests, in my opinion, CS2A you can finish in a day. Right, it also rhymes. How cool it is, right? Right, in a while you'll see that, you know, by the time you get to CS2C, yeah, even not even CS2C, right? By the time you get to the quest number 3 of CS2B, if someone tells you you have to quest number 4, right? I finished quest number 4 of CS2B. Someone says you have to get all the way through the blue quest before you can even start green. You'll say, hey, no problem. Yeah, give me 1 day, right? You can start in the morning at Tiger Named Fangs, and by night you'll be done with all, right? So in the beginning, it might have seemed a little harder to imagine, but now you can see how that is also possible, right? Maybe it's a little hard, right? Because you're maybe on quest number 9 right now, right? But I think that in just a little while, when you've been in CS2C maybe, right? CS2B, yes, CS2B, a couple of questions CS2B, you'll find that this is really, really cool. You can zip through all of these questions. That's why I've also made a requirement in the syllabus that there are people on the wait list, and you don't actually have to be on the wait list at all. Anyone who can send me, who can complete all quests up to 5 was it 5? I don't know, some number in the flow chart, in your flow chart too, right? So yeah, every quarter. But summer is going to be like half time. I can't imagine, right? I mean, yeah. So maybe these are people that really have done all this before, and they just need to pick up the creds, right? I think there are lots of people like that who've done this before. That's why it helps to be doing, teaching CS, computer science in the Bay Area, because there's always people who just want the creds, right? Formal creds. And there are lots and lots of people like that. And so for them, summer is perfectly suited, right? Because they don't have to waste a lot of time. They can just come in and just blitz through the quests and have some fun and on Reddit and pick up the creds and go. Yeah. All right. Do you guys want me to step away for a few minutes? We can start maybe even 8:30, right? So I'll tell you what I'm planning to do today. And then based on that, you guys can decide who want to take the screen today. Yeah. And it could be multiple people. I don't care. So here's what I'm thinking. What we'll do is create a class. We'll create a class, and in the class, we'll have some information in there, right? Well, some information. We'll pet and pet name and so on, right? I don't know what game, Teamster name and so on, right? Something there. But also we'll have a special member, which is going to be a pointer. Yeah. Okay. And here is a clincher. That pointer is going to point to an object of the same type as this guy, which means that whatever that guy is pointing to also has a pointer that's pointing to another one of these guys. Okay. All right. So that is really cool, isn't it? So we'll actually build it out. We'll build it out. It'll take us like 15 minutes to build it out. And even, honestly, it'll be nice and fun, I guess, if there was a whiteboard and I could draw it. Because we do it all the time. In fact, if you go to a YouTube channel, there's a bunch of videos of past classes, face-to-face. One of you guys recorded on an iPhone. And those were the first videos that we used to populate our channel, right? So yeah, it's actually fun to draw these things and loops and so on. And I thought we could do this now also with the iPad, and the pencil and the whiteboard mode in Canvas. So I think I tried that with your data representation class. I don't know, maybe I haven't got the hang of it, right? So whiteboard feels different still. So anyway, if need be, we can use it. Otherwise, you can look at those videos, or you can just basically just share your own screen and scribble on it to each other. That's fine. How about that, right? So that's what we want to do today. And then once we've got that working, we'll see, well, you know what, we've had all these other fun kind of structures before, right? We have Booleans, integers, strings, and then arrays. And then we also had the ability to create our own objects, right? So we had all these things to play with, right? This is how we look at it. In the beginning, we only had one small Lego piece, right? We got introduced to more and more different kinds of Lego pieces now. So that's what we have. Those are all the playthings we have. Now we're getting this incredible plaything, which is really one of the most powerful things you can ever encounter in the field of computer science ever, right? Which is really one plaything, the final Lego brick, which is going to be, you know, the Lego brick that you get is a special one, which in fact contains a link to the next Lego brick. That's all, right? Until then, you had Lego bricks, but you can't link them together. Now you got the final piece, which is the piece that allows you to link them together, right? So that's it. That's why this is the last bit of CS2A and the last lecture of CS2A, right? And it's the last part of our state assigned descriptor too. There's a CID for this class, ends with pointers and how to manipulate pointers. But I think that in the past, and also other instructors, maybe their style is different. But for me, I tried that, it didn't work, which was really in the past to, okay, this is pointers. And then now let's look at all these applications of pointers and so on. Yeah, okay, that's one way of teaching it. But I think that way you will get to appreciate pointers and really understand the nuances of it when I'm really not part of your life anymore, right? So you'll have all that enjoyment else some other time, maybe down the road. It sets you up for it. But I think that we can actually invert that whole thing, right? And say, let's not look at all the detailed applications of pointers. Let's not look at an example application that involves pointers, right? Linked lists and stacks or with using pointers and so on. Because you're going to do that anyway. But what we'll do is approach us the other way and say, let's just look at pointers itself as a building block, right? As a new kind of Lego piece you're going to be introduced to. And now and then that's it. That's the end of this class, right? And now you only have the finals and wrap up your class and you're done. And maybe I'll see you guys again, or maybe not, right? Because even if it's CS2B or 2C, we don't have formal lectures. Lectures are only by demand, on request. And I think it works out very nicely for those classes. So I think it's kind of nice that, this class basically leaves you with this last lecture basically leaves you with, in fact, the most powerful piece of all, which is the piece to link other pieces together. Yeah, right. Until now, you can build all these real nice, cool pieces. But the real power will only emerge when you can start putting them together. And this is the piece. And so I like pointers that way. So we won't belabor any specific application of pointers today. So we're not going to do, because I was thinking yesterday that we'll do stacks using pointers, right? Same old thing. And people have done this a million times. We've done this a couple of times already, right? Maybe linked lists using pointers. No, we already do it in quests. We can't do it. So what else can we do? And so we can concoct some fancy application using pointers, maybe games using pointers. Yeah, okay. But we've done enough games already too. Yes. So you've got a taste for all of these things. So the one thing you're missing really is at this point, well, maybe you're not missing, right? The one thing that hasn't been delivered by CS2A, right, is an appreciation of that final building block that we're going to leave you with, right? So this is your dollar's worth, right? Whatever you paid for CS2A, this is and you say, all right, this is your block. Now you've got everything. Go ahead and do it on your own, right? Well, obviously you can come back for CS2B. And I don't do it in summer again, right? So like I said, do it in fall, and then you can, you can do the quests. You can do the quests in summer. Yeah, no stress. But so what we'll do in CS2B is different, right? And I don't know if you get this perspective anywhere else, any other computer science course, right? CS2B is where CS2A so far. All we have done, if you think about it, is only introduce the different pieces right? And finally, how the pieces get fit together. This block that tells you, here's how you can link them together. That's all you've done. That is CS2A, yes? Okay, CS2B, you say, all right, I've taken it, I've played around with this. I want to know now how I can make really cool things using this new block. Okay, I've done some of my own stuff, but I want to see what other people have done with this thing, right? So if when you get to that place, whether it's CS2A or any other art, right? After you know the pieces, you want to know, that is when you go on to CS2B. That is when you go on to Arch 2B or acting 2B or anything, whatever that B is, right? You say you've learned the nuts and bolts, and then you've gone and tried to build things and half-ass things. Maybe some of them are really cool, but you don't know if they're really cool because you don't know what other people have done. So you can compare and contrast and say, hey, you know what? If I did that, maybe what that person did in this part of their code, hey, this would be really cool. I can take my game to the next level and so on, right? So you get to play with these things. Now you start getting really curious. Say, I've done a lot of these things. What do other people have done, right? So, and what are interesting problems that I can solve with what I know, and what techniques can I pick up that other people know to use with what I know, right? In other words, you're saying I have all these pieces now. I know how to use these pointers. I know how to use these blocks. Can someone tell me how to solve that problem using what I have, right? I've tried this and it's kind of half-assed. It's not really efficient. It uses like 5,000 blocks, Lego pieces to use it. But that's a lot of money. Mom and dad are not happy. But this is my budget, right? So I can buy these pieces. Can someone tell me how I can make do with these pieces, right? That is CS2B. Now you come to CS2B and we'll show you some of these problems. They're really hard to solve using traditional ways, homemade programmers. They will solve it, but inefficient ways. And people who don't know better will say, oh, that's a solution. We'll pay $500,000 for it because it's a solution, because they can look underneath, right? So, and that's a problem. And but you played around and you've got to work, but you're not happy, right? So you got to get to the stage when you're not happy with what you've built, using what you know. And then you say, all right, I'll go and do CS2B. Now in CS2B, we can show you, all right, so this is a problem, right? So even though you've got all these pieces, there's a problem here because you can build all these pieces, but what do you want to make an exact copy of the same piece here? Right? This is next level, really, isn't it? So you've built this incredible structure with Lego, but really, is it a good enough structure that is useful for many other things you want to do, right? So maybe you make these, because we've tried these things and we've tried all these things. These are intelligent people talking to us, right? Really brilliant people talking to us. They'll tell us, well, you know what? It's really cool. Awesome, man. But you know what? We've also done all those things in the past. When we got given all these Lego pieces, that's what we did too, right? And it'll be good for us to know these things, right? And then they'll tell us we did those things too. And then we found, all right, it got old very soon, or it broke, or something happened. So we kind of sat together and figured out how we can do these things the first time itself without putting in too much effort. Right? Because, right, and then we figured it out, and this is the best way, right? And then so we say, all right, so that's what we learned in CS2B. All right, so we can solve it this way, and we get that. Solve it this way, and we get that, right? But this is how you can copy an entire Empire State Building many times over. Bam, 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 like that, right? Without doing things from scratch. So we show that in CS2B, and I think it's really, really good. CS2B. Once you get to that stage, and because from now on, you're not learning new Lego pieces, right? You're just learning new arrangements of existing Lego pieces, right? That's CS2B. And then in CS2C, CS2C is where you come back after having learned how to wield your instruments, right? And put them together in various ways. You come back and say, well, okay, now I'm all these problems out there that seem impossible to solve. Are there clever ways of solving them using these new tools I have, right? And then you look at all the other clever ways that other clever people have come up with, right? And then say, wow, that's interesting, isn't it? I mean, these ways of solving these things I would never have thought. Yeah, it's absolutely reasonable that you would never have thought of it, because before you didn't have these tools, right? You can go to an artist and ask them, how do you differentiate this, thing in complex space, right? So it's not their area. And but however, if with the same bent of mind, if they had all the tools, the mathematical tools, you can ask them, and they would apply the same reasoning and come up with the right solution. So all the reason now in CS2C, you say, I'll look at all the hard problems that people have been fighting with all their lives, so many. I'll look at it and see, and I have these new tools, right? Maybe nobody has even thought of using these tools in this particular way. Right? Who knows? Like, take a little, sledgehammer and shove it in there in a way that hammers are never used, right? Maybe it connects two things and, electricity, right? So, yeah, like that, so that is to see, and you find out interesting and clever ways of adapting what you have to solve these complex problems and then you get to appreciate what other people have done. Right, that really is college education up to research level. Right, you don't have. I mean, you should. I don't think that you should not be a researcher anytime. You should always be a researcher. But I think after a certain point, you get paid to do research. Right, so when you get to be an RA or research or PhD person, they pay you to do research, and then you can focus on it 100% of the time. But where was I going with that? Yeah, I don't know where we were going with that. Yeah, but so yeah, when you do research, yeah, that's right. So then you can look at all these problems that other people have, are trying to solve, and say, are there interesting ways in which I can use these, Lego pieces that I've built, the complex Lego pieces, not the basic pieces, right? So basically, you have stocks. You have a stock Empire State Building, a stock. Taj Mahal, and so on and so forth. Everything is stock pyramids and so on. So basically, what's good where, right? Yeah, this casino, you can't build it like an office. You got to take one of those, right? And just like you do it in Unreal or something. So you just pick the right blueprint and drag it in place. And that's what happens. And then connect them up in wires, right? Connect them up and say, well, at this point, I need that list to be sorted, right? And now in CS2A, we're struggling with sorting things and understanding how sorting works, right? But later on in CS2B and 2C, you're going to be using sorting itself as a tool, right? You can say, oh, you know what, in this complex algorithm, this will work only if that piece is sorted. So I'll call that routine to get that sorted for me. Oh, this needs to be structured like a complex linked structure, right? So I'll call that piece to do that. So you get all that and start weaving together complex works of art. And that it really is what tends to happen, right? In any field, I guess. All right. So anyway, that's enough of me blabbering on and on. Well, look at that. It's 8:31 already. Right? I promised to give you guys a break. You still want a break? A 5 or 10 minute break. I can take off if you want, right? And then when I come back, we can start coding. Do you want that, or would you prefer that? Right? Just raise your hand if anybody would want that, and then I can just take off for 5 minutes, right? And then I'll come back when I hear silence. Is that okay with you guys? I don't know. Nobody's raising the hand. All right. Hey, Peter, you want to raise your hand? Okay. All right. You raised both hands. Okay, cool. Yeah, all right. You can finish it off. What I discovered was he really likes the apricot stones. So on the way to Trader Joe's, there's a street side apricot tree, right? Right next to a loquat tree. So a couple of months ago, loquats were in full fruiting season, right? So I, plucked a whole lot of loquats on the way to Trader Joe's and made loquat preserve. And a few days ago, these apricots, the tree was basically being weighed down with these ripe apricots. So I just got a whole bunch of them. And so yesterday I said, what am I going to do with all these apricots? So I made apricot preserve, right? So, and it turned out really beautiful, right? But I had all these stones. I had almost like a whole bunch of them, apricot stones. And I said, what am I going to do with this, right? So, and I was ready to toss it out. And I said, let's see if Peter likes them. And I left it out there. And within a matter of hours, a couple of them had come and just finished off. Right. And I, how hard the plum and apricot stones are bite into. Yeah. For these guys with their teeth, for them is no work at all. I can go and look at them and this really hard stones, and half of them basically chewed away. Interesting. So yeah, cool. So I have a use for a whole fruit now, for the whole plum or a whole apricot. All right. You want me to step away for 5 or 10 minutes? Yeah, we can start coding, 8:45 even. 1 hour is enough, just the last class. Obviously I can answer questions if you want. You know what? We don't have to code pointers, honestly. Why don't you just pick up a video? Why don't you pick up a video from one of those we've done this for a couple of quarters now, right? Code different kind of pointers. Unless you have a question and you want to work through an example, or you want to code, right? You want to code a pointer, that's fine, right? Pick up the screen, I can help you code a pointer. But there's so many videos now, even our own videos or the videos on YouTube. There's so many how to work with pointers. But I think it'll be cool. Just watch some of our past classmates, right? Now you senior students. And in fact, some of those students who are doing 2C now, actually that'll be fun, right? So because I'm answering some of their 2C questions, it's really cool, right? So I'm answering some of their 2C questions on the subreddit, and I can remember some of them in class, like you guys, right? In CS2A. And it is so cool. And they're asking these really, really sophisticated and profound questions, right? And things that you would not even imagine that yourself asking in like a few quarters, right? And they're asking questions like 2 times removed from a pointer and things like that. It's incredible. And they are these people that in my lecture they were coding on screen, and it's incredible. So it's so much fun. So I think it'll be fun if you guys also watch those videos, because then that'll give you a sense of how you can then look at yourself in these videos in a couple of quarters. Yeah, Rishabh.
Yeah, I was just like wondering, like basically when you're talking about like CS2C and the students there, like like basically being at a much more advanced level at A, right? I was just wondering, does that like do they tend to like I don't know how to say it, like do they tend to ask for help a lot more in the forums, or are they like much more like
No, it's exactly the same. Same frequency, just the kinds of questions. Just yeah, the kinds of questions you ask will be will start getting more and more deeper, right? This is less and less comprehensible to a fresh CS2A student.
Okay, so is it like more like contrived problem solving questions, or is it more
no, nothing contrived. This is straightforward questions. Yeah, I don't know how to describe it because there's so many different examples. Or you just go to CS2C, the red subreddit.
Oh, yeah.
Yeah, just go to the red subreddit and look at some of the questions. And then and you can click on a student's name and look at their entire history and all the questions they've asked, starting from when they were doing CS2A. So they have questions in the blue subreddit, they have questions in the green, and also the red subreddit, right? And who knows, maybe some in the future they might have articles in Stack Overflow or Wall Street Journal and in magazines citing them. So it's all pieces that you can link together into some story, one of the many stories you can have in your life, and this could be it, right? And also think about it as I don't know how many of you are going to eventually apply to research institutions and higher education institutions. Think of this as also a portfolio, right? Because if they look at art classes, in art classes, people get to build a portfolio, right? Even in high school, you can just enter even a bachelor's program in art today, unless you send to the college a portfolio. Yes or no? I don't know if any of you have applied to art classes, right? So you got to send them a portfolio, and they'll say, well, where's your portfolio? So if you're a web design or digital design, you got to have an interesting portfolio. So for computer science, computer science at the end of the day is really an art, isn't it? Yes, Rishabh.
Yeah, I was just like wondering that do you need to, is it okay to put our lab solution on a GitHub repo? Because I know that there's been history of cheating on
I see. I totally, here, think about it this way. Is it okay to just publish the endings to all of the suspense stories on the web, or spoilers to all games. No, sometimes it's worth it, sometimes it's not. So just exercise good judgment there, right?
Sure.
Because if you just put the solutions out there, maybe it's just going to spoil the experience for other people.
Mhm.
On the other hand, on GitHub, you can put pointers. Well, why even GitHub? Just write up a bunch of really, really good documents on CS2A, on the quests and how to approach them, and tricks and gotchas and things to watch out for, and then put them together with the spec and put a little booklet together, right? 99 cents on Amazon Kindle, and maybe that'll pay for your college, right? We'll make that recommended text for CS2A. Yeah, I'm pretty sure many of the students who enter CS2A would benefit from a small booklet written by a senior student, 99 cents, right? And they'll fork out 99 cents to buy the book, because it shouldn't give out solutions, right? Because if it gives out solutions, I'm not going to recommend it, right? So it should give out interesting tips, pointers to links and so on, right? And then someone like you would buy it and say, all right, this is how I do the quest. Well, if it gets too if it gives out too much information, I'll have to change the quests, right? So hopefully you'll give out just the right amount of information. I can help you there if you want. So there's so many things you can do. But I'm saying that, at the end of the day, really, programming is computer science and programming really is an art, right? Because you're learning all these tools and how to apply these tools in different textures and so on and so forth, different places. It's an art. And just like any other art, you need to have a portfolio. When you get to any school, you need to have a portfolio. And this is a way of getting a portfolio done, is having something on Stack Overflow or private channels like Discord and so on. They're good for games, and right. But really, you want to build a portfolio, and you want to build stuff that you're proud of, and you want to build stuff that to make other people's life easier, fun, happy. And so do it on public forums. Right, and then that's your portfolio. And just like any other art, and also I think this is a problem with life also, right? In general, I can make this generalization, at least from the different rates at which my own life has progressed up to now, is life is also right. The programming as an art has a rhythm, right? So because in musical, if you take music, notes have to fall on the dots, right? If they're shifted, it doesn't sound like music at all. And then there's even in the mind of the creator, there's panic, of the player, there's panic, they can catch up, and it's all messy. So, but once you get into the flow of getting each thing on the note, bam, 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 then mind just frees up, right? Because you don't have to worry anymore. And then you get into the flow, and everything just happens. Everything happens, and you just be a passive bystander. You're seeing things happen, just nudging things here and there, so that it just happens right direct. And everything just and you can see that's the flow in an art, in programming too. And I'm pretty sure you've experienced that, right? So sometimes when you're programming, you just get into that groove, right? And then you're not really pushing for anything to happen, and things are just happening and just nudging things along, and it happens, right? And that's the flow. That's what program is called, flow. And that's a flow in music too, right? It's a flow in music when someone starts playing a piece and then they just remember finishing it, right? And you remember memories of it and so on and so forth. But and you have to get into the flow. And I think that programmers have a block and a struggle and a tough time when they don't get into the flow, when they're forcing it, right? Forcing it either when it is not their natural speed, or meaning they're probably going too fast or too slow. Right? Because if you go too fast, even in music, you have only certain faster speeds, twice as fast, 4 times as fast, right? All of those are appealing, right? But there are some non-geometric times, fractions of the speed that just don't work at all. It's same like that in programming, right? So you will be taking a huge risk if you're saying, I'm going to go fast, but I'm not going to go as fast as is required, right? So if you're going to jump, you got to jump and land on the next safe spot of land, right? If you're not confident you can make the jump, you shouldn't jump at all. You just stay where you are, because even your float is moving forward too, right? And you can be happy. And I think that's the problem when people who are trying to go fast are going fast at a frequency that's not at their own, right? And they're out of resonance, and they fall into hot lava, and they just give up hope. And I think that if you just get into the groove of programming, that's why I said don't do CS2B in summer, right? It is not the natural groove for most people, right? The only the people that it actually suits, the summer terms, all of those summer classes suits, are people who already know what they're doing, and they just need to pick up the creds, There are a lot of people in Bay Area, and that's what we serve, right? So I'm just being frank, and I just tell you what it is. I think that's what it is. In the summer, it's only people who just need the credits who do the course, right? People who want to enjoy the ice cream will basically take it on a Sunday, right? Not over a 5-minute recess. All right. Why is, well, that's right. We don't have to code, right? So we don't have to code. But if somebody wants to code and something particular needs coding, or someone is interested in coding, happy to do that. One of the things I want to do over summer is basically just categorize all those videos, because I think we've done these videos for 3 quarters now. So I think for each week, I think we have 3 videos. So I'll experiment with this in summer, maybe. So what I'll do is in Canvas or Reddit or somewhere, I'll say these are the week 1 videos that you need to watch. Right? So I can just have, these are the week 1 videos, maybe 6 videos there, right? Tuesday videos and Thursday videos. And if the summer guys like it, yeah, I don't know, fall. Well, fall, we could say either that or have a live class somehow. We'll figure something out. Any other questions I can answer, or are you guys happy enough with what you learned so far? Is that enough? Are you happy enough to tackle pointers and question number 9 and then take it easy until, not easy, but you keep working on it over the summer break. Try and find new challenges. I don't know how many of you are actually ready to take a proper vacation, in the sense that you're a vacation from the world, right? Vacation from the world, meaning you're absent from everybody's life, right? Everybody thinks, but on the positive side, they know you're not dead, right? So you're not dead, gone. You're gone for 2 months. So you got to go. You got to leave everyone for 2 months, and just focus on this. And that 2-month investment, provided you don't lose it, right? Because there are lots of people that are vying for it. I'm not just meaning, I don't just mean humans, right? There are lots of humans who also want your time, but there are lots and lots of non-human entities also that want your time, right? So there are games, there's Facebook, there's lots of things that want your time. So you got to be very careful and budget your time and say, well, maybe I have all these entertainment avenues, but even Facebook and Instagram and all these things, I'm just going to say I'm on vacation for 2 months, and I'll come back and pick up Facebook after 2 months. Right. So let's, if you're willing to do that, I think those 2 months will just come back as an enormous reward, later on, because you can just go back to it, and then in college and later on in life, you'd say, wow, aren't I so glad that those 2 months I just gave away. So yeah, I think just pick up a skill, right? I think there's a bunch of you already who are doing things like that. So maybe even get together. Maybe even get together and say, well, even though it's a vacation, it's going to be a joint vacation, right? So the only things we're allowed to talk are about what we're doing, right? And maybe pick up a group project and do things, and always, shoot towards a common goal, right? No matter who does it. And anytime at all, if you guys want me to get together as part of the group and give you a group video, a group Zoom, or a group direction, or walk you through some of the code, right? Or blueprint diagrams, I'm happy to do that, right? Or even planning phases, or even launching on the cloud, or whatever it is, right? I'm happy when you get to the right place, happy to do that. Whether it's one person or a group, it doesn't matter. But if it's a group, it's better, right? Because you'll have multiple people, and eventually, without one person saying this is what you should do, this is what you should do, it'll some kind of structure will automatically, naturally, organically emerge, as long as nobody is vying to be the captain, right? Nobody wants to conquer, right? And just says there's so many interesting bits here, I want to chew off here, I want to chew off here, and lots of people keep chewing off at different parts. And even if this continues, if 2 people want to do the same thing, you can always talk to each other and say, hey, I want to do that too. And it'll be fun. And then eventually you'll find that there's pieces that you want to do that other people will say you can do it, right? And then you can natural order will emerge. So I think that'll be a fun exercise, right? A bunch of you can get together, and it's just a couple of months of your time. It's not going to cost an awful lot, I can be sure. And if you have your basic accommodation and basic needs covered, I think you can just take off for 2 months, right? And I'm happy to come by anytime. especially if there's a bunch of you working on something. Any other questions about CS2A, about CS2B, about computer science? Well, not that we're just going to take off, right? We have an hour. You know, I can also give you time. I can take off. Not take off, right? I can switch off the video. I can switch off the video and hang around until I'm called, right? Unless you have any questions, that's fine too, right? Or if there's any topic that we haven't covered, anything that is you're still doubtful about in computer science, or I mean CS2A, anything within CS2A that we haven't covered so far, right? Pointers. I know we haven't touched upon, you know, linked lists and stacks and the use pointers and so on. But really understanding what pointers are, appreciating that link, and just saying, wow, now I've got this thing that allows me to connect things together. That itself is pretty awesome. So that's all. If you have any questions, do that. And obviously, if any of you want to have a run at it, if you want to code, you know, live code a pointer, pointer based anything at all, just pick up the screen. I'm happy to walk you through that too. Right. Otherwise, yeah, just feel free to talk. Right. No silence. Right. Or the only thing that's not permitted is silence. Because yeah. All right. Someone Mark said he's going to take a break from the class over summer. Hey, congrats. Yeah. All right, cool. Yeah, that's fine. Yeah, no, yeah, you shouldn't do it in summer anyway, so you should do the job. And yeah, but it's related to computer science, so that's pretty cool. That's very nice. Awesome. Anything else? Anything else you want to want me to explain further, or any particular concept that is still a little confusing? I can talk about that if you have questions. Yeah. Do you guys just want to drive and do things for a few minutes before? Yeah. You want me to just? Do you guys want to just type and experiment for 15 minutes? And then we can, what time is it now? 8:50. Yeah, we could start at 9:10 or 9:15 and then still continue our conversation. And if other people have things that they would actually like to see coded, or if you, in the process of experimenting, you got stuck with certain problems that you need to you know, solve together with me, I'm happy to do that too. Is that okay? Like, I think that happened well last time, right? You know, I think Turkey was coding and a bunch of you got together and you were saying, hey, let's try that. And you tried, you know, and you got a bunch of code. And then eventually I came back and you had some tweaks to make, and then and it all worked. Do we want to try that again? Yeah. I don't know. I'm not getting any feedback from you guys.
Yeah, we can try that again.
Yeah. All right. Good. All right. So in that case, what I'll do is I'll just stop the video and I'll step away for a sec, and then and you can call me, right? I'm going to mute and stop the video, but I'm still hearing. You know, I can still hear you guys. So if I just hear my name or professor, I'll just.
All right, so what should we do today? Last time we were doing the teams. That's the code I was working on.
Yeah, sure. I think we had a sort algorithm last time we were there.
We create a store. Are we just going to test the pointers in this one? Like after we create the values and stuff and see how we can put that out?
Yeah, sure.
All right. What should we have as in the store? Let's say aisles. And should we make them vectors?
Well, I mean, if it's just the total number, I don't see why. But
Yeah,
if we're
why
talking
would-
about the files, yeah.
So if we think make a vector and instead of and the num, we can just make it the size. I think if we take it aisles and stuff like this, we'll end up creating an array instead of a vector. So should we do it vector too for the number of shelves? Or should we just assume that the number of shelves can be, let's say 7 shelves per aisle? So let's just assume they're all 7.
Would it be possible for us to have specific number of shelves in each different aisles?
I mean, technically, we can just put the aisles value to that number of shelves. So we know, let's say, vector 0, which is aisle 0, have like, let's say, value of 7. So we know 7 shelves in that aisle.
I have a kind of shallow question. So would it be possible for us to have 2 different arrays in one vector? Like we contains the number of aisles and have a number of shelves in each aisles in one vector. Would that be possible?
I
Yeah,
mean,
that's
we could
possible.
do an array. Yeah.
I see.
Wait, sorry. Can you like just specify what you like? So are you trying to like put an array, like a vector of integer arrays, or are you trying to do something different?
Well, the first one we tried is I was thinking shelves per aisle, and we have just one unique number, or each aisle. When we address it, we say, oh, aisle 0 will be 3. So it means 3 shelves.
Oh, oh, I thought you wait. So those are grocery shelf aisles. Oh, okay.
Yeah, we're in a store. But yeah, we can think about it as an array if you want, but I don't think would it? Yeah, I think it would. Why not? Let's see. How can you declare an array in C? Do we need to include the library for it? Or wait, we can create a matrix. I'm sorry. Any input?
Sorry, what are we doing again in terms of?
We were thinking either we do the vector thing, so each aisle have a value of an int, and that means that aisle have that many shelves, or we mentioned that like a way we can do it just as an array. So we have an x and y value um, for each element of that array. So we can store more values, I guess, but
We also do object vector.
an object vector.
Yeah, have aisles be a vector that contains objects.
Vector. Let me know if I'm typing it like wrong or.
We'd have to name sort of the object, so maybe store. So we do a similar thing in the pet store,
Oh, I see. What you mean.
if you remember.
Like this.
Yeah, like that.
So
Makes it a little more complicated though, because this would have, I mean, at least when I implemented the pet stuff, it caused all sorts of issues. So I figured out how to do object vectors.
and the object vector will be like, can we declare each aisle with their items in them and everything?
Yeah, that'd be the idea, right?
Yeah, I because it gives you more options to add more values to it, does it? Okay. All right, so you guys tell me what's next.
So I guess the next idea would be to populate the objects themselves with properties that are relevant to the context, right? Sort of like what would go on the aisles, or what sort of properties the aisles would have.
Can we say, for an example, limit? So we make a program, let's say, checks if the if the shelf and an aisle need to be stocked.
Yeah, that sounds pretty good.
So let's say, can we put a limit? Can we create a value for as limits, or should we just keep it as is and we determine in each? I was thinking later on we can create a random value that fills the values in the aisles as random, so we can show, for example, these are the ones that we need to stock, and maybe we sort it by from the emptiest to the fullest. To sort and pointers, maybe.
That could work.
So I'm just gonna add this and keep it loading. So we have a shelf capacity. So even if we created shelves at the aisle, regardless how many, we know there's a capacity. Maybe we make it a value that we know. Let's say 5. So how about our constructor? Let's say takes a value of how many aisles in your store. So we'll take this as an integer, maybe.
Well, you're not going to have partial values. That makes sense.
Would we say how many items too we take from it in the constructor?
I mean, yeah, for now.
maybe we resize the vector aisles based on the number of aisles.
Yeah. Just
Aisles.
aisles dot resize aisles.
And the number of items divided by the shelf capacity can equal how many shelves we can have in the aisle. I don't know how we go with, like, I don't know what is the end result of this. Are we trying to stack, like, because if we did it that way, we'll try to get like, how many items can be in each aisle? I don't know.
Yeah, I'm really not sure what the goal is per se. Just partially why I'm not sure what we're doing.
I mean, you can call the professor at this point. Maybe he can take it from here. Does anyone have an input?
Oh.
Nope.
Anand, are you there?
Professor?
Yes.
Mostly we need a
Yes.
goal.
Yes. Yeah. Can you hear me? Can you?
Yep.
Yeah. All right. Good. Good. What's up? What's up? Let me increase the. First of all, let me.
We wanted to create a class called store and just have a vector of aisles that we assign the number of shelves as values to each item in the
Oh, I
vector.
see. I see. All right. Store, and it's got a shelf capacity 5. And it has a vector of. Oh, why is the vector of type store?
We thought maybe down the line we wanted to add more items, or if you want to have
Okay,
varieties. Or,
so I think you want a vector of items in the aisles, not vector of store, right? Because you have a store, and then in your aisles you don't have other stores, right? Items, and then you need another. No, item, because your vector of items is your items. Yeah, and then you need a class called item. Yeah, then it'll work. I think. Right, and then you can have an item name and item cost in the private string item name, and then have integer item cost. A lot of people that work with currency make the mistake of using floating point numbers in currency calculations, which is actually not a good idea. It not only is inaccurate, but I think it slows things down. Just keep everything in cents.
So we create an aisle of.
Here's one of the cool things that you can do, Turkey. Just go back to your item for a sec. Right now, initially you want the item, but you don't want to flesh it out completely. So just make it a class and everything is public, and get rid of the, make the private into a public. No, just turn the first word into a public also. First word, public, make that public. No, make the first word also public. And then put a comment, 2 comments to do, and then, to do, encapsulate later or something like that. To do will do actually. To do on the public is self-explanatory, right? Put it on the same line as a public, then it's self-explanatory. People know that needs to be made private, which means it needs to have getters and setters and things like that. For now, you don't even have to worry about anything, not even the constructor, right? You can get rid of the constructors, and you don't need anything at all. And you're just using essentially this item class as a container, a bag, which allows you to have a vector of items. And in your vector, you can basically say dot and then get the item name and cost and everything you put in the bag. Yes?
Yeah. So we do have the item name and the item cost. Then we do have the shelf capacity, which is like 5 items per shelf in each aisle. But we
Oh, I
were
see. You
thinking,
have a shelf each. So yeah, I guess I'm not. Yeah, I'm not.
have
I
a
don't
feeling we're
understand the
gonna need
exact
a class
structure of your
shelf.
store. I don't know what your aisles and shelves and things and items mean. So a comment there would help to say a store contains many aisles and each aisle contains many items. A store contains many aisles. Each aisle contains. No, AISLE. ISLE means an island. By the way, ISLE means island. AISLE is that thing in the supermarket, in the grocery store. Yeah, aisle, or in an airplane. Oh, how come you don't have this refactoring thing in this in your
I get scared when I have a lot of classes. I don't want to use them with a lot of classes because sometimes it can mix up. So, but yeah, it should be better. Okay. So we do have number of aisles.
No, the comment. I don't think you're finished with the comment. Yeah. The store contains many aisles, plural. And then on the next line, you can say, all right, each aisle contains many items, right? And each item has a description, a name, and a cost. You can go on to the next line. I think it's going to be, yeah, that's what happened. Has a no DE why didn't autocorrect? I don't know. It's P, not a B. It's not voiced. PTION. This could, no, you got the T and P. You got it swap. Yeah. Oh, it's your mouse. Your mouse is on the description, so I can see the full spelling. Yeah. I thought it was my mouse. And also a name. You put a name, a description, and a cost. So you can embellish the game a bit more, right? You have three properties inside of the thing: name, a common description, and a cost. Okay, so then you shouldn't have it called shelf capacity, right? Because you should keep it in line with your comments, and then you should say num items, num aisles, number of aisles, right? Number of aisles, num aisles, AISLES. Yeah, and then you can't say equals 5 right there because I don't think that maybe in the later thing it's possible. You got to set these values in the constructor, right? You have to set these values in the constructor. Okay, and then let's fill out the other things too. And number of what is it? Number of aisles, and then the number of items per aisle, right? You need to have an int on number of items per aisle. And it's good that we'll have num items per aisle or num of items. Yeah, get rid of the off. We'll say num items per aisle. And then it's good that we are, I was about to say something was good and I forgot what it was. All right, I think it'll come back to me.
Okay. I think we wanted to have the limit. And maybe that's maybe you were talking about the limit that we had.
Oh yes. I was talking about the limit. Thank you, Chucky. Yes, it was definitely something about the limit. Yeah, we had the assignment there. Maybe new version of C++ allows you to do that, but we should be doing it in the constructor. No, it was related to it, but it was something else. It'll come back to me. All right, let's do it in the constructor, right? In the constructor, you say, let's give it default parameters. Int num of aisles equals, let's say 5, which is a default. Num of aisles equals 5. Yeah, just say equals if equals 5. No, in the parameter list on line 39. On line 39, yeah, go to line 39 and say don't say num of isle, because it means it is the isle number. It's not the it's a number of isles, so it's num isles, num underscore isles, AISLES underscore, and it's got to be plurals, right? Because if it's not plural, it doesn't mean it's a number of. It means, yeah, num isles, yeah, right? And it's got to be num items. And you got mixture of camel case. You got two different. So it's a capital I and, yeah, and the other one also. All right. So now in here, all you need to do is say num isles equals underscore num isles equals that. And oh, by the way, no, yeah, right there. We haven't completed in line 39 yet. So on yeah, int num isles. Where is it? Here on line 35. On line 35. After num isles. Say equals space equals 5, and then num items on each isle equals I don't know, 100 items on each isle, 100 items in each isle. Yeah, is that, in fact, let's make it clear and say num items per isle. In fact, let's make that num items per isle. Yeah. All right, and this should be equal to 100. Yeah, okay. And now all you're going to do is say the underscore thing equals this, and the underscore of this equals that. That's it.
Professor, may I ask why the constructor store and deconstructor store is in the public?
Where's the where's the empty constructor? I don't see the empty constructor.
Isn't that store?
That's a destructor. That's a destructor. And by the way, the spelling is wrong. It's got to be uppercase store, uppercase S for the store. And you don't need the destructor because we're not allocating memory, right? It's right now. And even though we know how to use heap memories and pointers and allocate with new and delete and stuff like that, we shouldn't do that unless you absolutely have to in many situations. Because when we use these containers like vectors and all these things that the standard library provides, we don't have to use destructors, right? The standard library takes care of these things. So I don't know. Let's not use destructors here because we're just going to use. Here's a thumb rule. Okay, so here's a thumb rule. If you don't have any new or delete in your constructors, right? You do not need to have any destructors, right? The only times you need destructors are if you have news in your constructors. If you don't play with the heap and use heap memory, then you don't need to have destructors. Okay, all right. So is this fine? This is the constructor, and is that okay? Now you can make this constructor inline, right? I can show you how to make it inline, right? So so let's just do one more thing just to make it inline. Okay, on the end of the line 35, on the end of line 35, just space and then put a colon. Yeah, no, colon, space colon, right? Colon, right? On the next line, because it's going to be long, we want to put it in 2 lines. On the next line, indent in. Yeah, all right. Now you're going to say underscore num isles. No, you can't say equals, right? This is a different kind of, this is called the chaining kind of initialization, right? So I'll show you how this works, okay? No, AI, yeah, it's actually auto-completing it, even a part of the thing is fine. Okay, open parentheses, right? And you say num isles a parameter now. All right, now, now comma. No, you say comma, and then initialize the other one also like that. Right, now, initialization is done. No, don't put the semicolon there. Before the semicolon, say that the constructor is done. There's nothing else left of this constructor, and you indicate that to the compiler by saying just open brace and close brace, nothing inside, right? Space, and then no, brace. Yeah, that's it. Okay, now you can get rid of the constructor. Line 39 to 44 can go, right? That's it. That's your constructor right there in one line. It's done the chaining. This is called the chaining initialization. Basically, if you're passing parameters, all right? And the parameters are objects or some, right? You can say these are the initial types, and you just chain that and then call the body. And in fact, after you chaining, after you do that, the body, there's nothing in the body, right? So that's it. So
When you
that's a
say
very
brace, do you mean curly brace or like the solid brace?
I'm sorry. Oh, well, there's a curly brace. Doesn't show in your font.
Well, 36, it is curly brace. I'm just asking if that's what you meant.
Curly brace. Yes, I meant the curly
Okay.
brace. Yes. Sorry. Yeah, it's kind of cool, isn't it? So that's basically a store class. All right. Now, oh, hang on. Number of items per aisle is 100. Okay, that's a default, and the number of aisles is 5. Okay, so in your constructor, however, we need to do a bit more than this, right? It's not just initializing variables, right? Yes. Okay, so let's do a bit more. I just wanted to show you how this is, right? So that's why we went here. Now, what we'll do is not do it in line because we want to do some vector resizing and all, right? So let's pull it out. So get rid of the inline thing. Yeah, right, and get rid of it. Thank you, Turkey. Yeah, so you are already anticipating this, right? Get rid of, no, there's a colon, and turn that into a semicolon. Semicolon, you have a semicolon. Right, now you've got, no, you don't need these because now by the time you get into the body, that's already been done, yes? Oh, no, you have to. All right, we'll do a mixture of what we did before and now, right? Get back what we had. No, don't delete this. Don't leave this alone. Get back what we had on the previous line, right? Except what's inside of that, the curly braces, right? This is one more way of doing it, and it's a useful way to do it, right? So on the previous line, go get back on, yeah. I thought you, yeah, it was in your buffer. Okay. Not equals, you got to do in parentheses. You got to chain the chaining in it. It's called chaining initialization. It's a new kind of initialization, but it's a useful one. Num items per aisle, right? Now do a semi. Is that it? No. Now it's not empty, right? You go put a semicolon there, right? And get rid of the braces. Get rid of the braces. Right now, it's a regular.
Isn't the first one should be the number of aisles? Right. It's.
Yeah. Chanyi is right. The first one is number of aisles, not number items per aisle. First one is number of aisles. That's why I was thinking the line was very long. It's number of aisles. No, even the parameter, even in the parameter also. Inside, yeah, number of aisles. Great. Yeah, now I think it looks much better. No, num aisles, yeah, very. All right, now get rid of the, yeah, there's some funky thing, yeah, get rid of that. Yeah, get rid of that line. Line 37. Oh, I see. Yeah, that's good. Thank you, Turkey. You can also talk, by the way. All right.
Yeah, my bad.
All right, no, that's fine. So, all right, Chanyi, are you happy? Is this good? Now, this is the same as what we did before, except we're saying that you have to do this chaining kind of initialization of the parameters to your values. However, the body is not empty. No empty braces there, which means that the body is still there. It's either going to be following in line, or it's going to be out of line. So we're going to do the same thing as before. The only thing we can skip here is that we don't have to set the values of those values of these things because they've been set before. So now go back to line 42. Yeah, now those two can go because those two have been done in your inline chaining. Yes. Okay, now all we need to do here is now resize the first vector. You got to do two things, okay? If you don't do both of those things, you'll have a problem, right? Aisle.resize to num aisles underscore aisles, right? And then you got to do a for loop over all of the aisles, and each aisle should in fact be a vector of items. Yes. Okay, so I think in your store, you also need public, right? So so this class, say this is going to get slightly complex, but bear with me, it is like totally worth it. Okay, all right, so here's what we're doing now. After we type it in, you'll understand what this is. Okay, go to the private part here, right? So line 30, go to line 30. Okay, this is our store. Okay, this is our store. Vector, type in vector, standard colon vector or whatever, vector, right? Okay, and now it's going to be a vector of something. Yes, but it's going to be a vector of aisles. Yes, but what is an aisle? An aisle is a vector of items. Yes or no?
Yeah.
Okay, so an aisle is going to be a vector of 100 items. Mark, each aisle you have 100 items, right? In each aisle you're going to have 100 items. So you can actually treat each aisle as a vector of 100 item types.
Can't you just make like an array of like?
No, a vector is an array. Forget about arrays, right? Arrays are really hard to manage on their own. We'll just use vectors all along. We know what arrays are, but we'll use vectors, right? Unless it comes to, when it comes time to squeezing every last cycle out of an algorithm we write, that's the time. You say, I'm not going to use a vector, I'm going to use an array because I need to use these very specific comparisons and stuff like that, right? So these things I can get rid of. Otherwise, you should just use vectors. I think this is my, you know, I mean,
So it should be the item in the square bracket.
however, yes. However, we're going to do something differently here. This is not the right way to do it, but we're going to do something in a different way, but it's a correct way. It is one way to do it, but it's not the best possible way, right? And then you'll know why it's not the best possible way, right? So because you can, the scope, and we'll do the refactoring here too, right? So we're going to have a vector of aisles. I want Mark to be okay on this, right? Where's this Mark gone?
Oh yeah, no, that's fine. I'm just thinking about what we're gonna name it.
So store,
like a store.
yeah. So each aisle is a vector of 100 items. We'll say 100 for now, right? And a store is nothing but a vector of aisles. Yes. A store has 5 aisles in it. So you can say a store is 5 aisles, a vector of 5 aisles, not 5 items. But each aisle has a vector of 100 items. You can do it that way. However, we are going to do it the harder way, just so we get a chance to play around in this territory. We're going to say we're not even going to define an explicit type called aisle, right? We'll just assume that a vector of items is an aisle. So we're going to define it like this, right? Instead of having an explicit type called aisles, instead of AISLES inside of those angle brackets, type in a vector of items, because a vector of items is an aisle. Yes. Okay. No. It's inside of that. You say vector of items, not items. It's a vector of items. All right. Okay. So already we're getting. This is not even CS2A territory. Okay. So we're past CS2A territory. We're actually looking at question number 3 of question number 2. I think maybe.
Wait, Professor, do you mean inside the square bracket we put another vector, right?
No. Inside the angle brackets, you have to say vector. It's a type vector.
Yeah. Vector.
Just type vector right now.
So it's vector inside a vector.
Yeah, vector inside a vector, lowercase v. Yeah, vector. Another angle bracket is a pair. Another angle bracket inside of that. No. Don't leave. You just leave the mouse where it is until we right. It's the same as Rishabh too, right? We can save time here. Just go inside the angle brackets. Don't move until we've done, right? Because we're in this territory that we need to be very close and step. Okay, right there. Put another angle bracket. Left angle bracket. Less than. VS Code is getting in our way, right? There's an autocomplete thing. There's got to be some way of turning these things off, right? Okay, all right. You close it, and then we'll go inside and type it, right? Yeah, go inside now. Go inside. Now inside, you're going to say item. All right, and then that is just going to be a store. So underscore store. No, not just yeah, right there. Double click and say underscore store dot let's just say, what do you call it? Because our class is already called store, right? Store dot stuff. I don't know. Store dot items. They just called it items. Items was better.
Inventory.
Yes. Oh, sorry. No,
Maybe
not
inventory?
I'm sorry. I was thinking of how you would use it. You were coming up with a name for this variable. It's not dot, right? You say underscore items. Just say underscore items was good. Just say underscore items. Not store items. Okay. Yeah, I think what you had was good. Store items. Okay. Yeah, that's good. I think I was thinking of a way in which we can distinguish this from the store variable. All right. So now in your constructor, right? All you need to do is resize, not aisle.resize. What is it? Num aisles. And you guys say store items.resize num aisles. Store items.resize num aisles. Yeah. All right. Now now you're going to, inside of each of those store items, you're going to resize each of one of those to number of items, right? So you're going to do for I equals 0. So you're going to say for j equals, you start another nested loop here, right? For j equals 0, j is less than, j as a semicolon, and yeah, j is less than, number of items per aisle. No, is it, what is it? No, you got 2 loops already, right? Have you got 2 loops? So you're going through the number of aisles, and then each one. No, you don't need 2 loops. Only 1 loop. Sorry, I'm sorry, Turkey. Right? Just get to the loop, and instead of the for loop, you're going to say you're just basically going to type store items of I, store items square bracket I, square bracket I dot resize. No, dot resize. Right, to what is it, num items per aisle, or whatever it is, whatever it's called. And you might as well use the private member now, because it's been set, right? Instead of num items per aisle, you can just say underscore right there. Just put an underscore right there. Yeah, okay. So those 2 variables have been set already in your chaining. So now this is what the constructor does, and it's only 3 lines, but it's really 3 powerful lines, and it introduces a data structure that is very important, all right? Because it is not linear anymore. So I just left for 5 minutes, and already you guys have created something that's, mushrooming, and it's really cool, because this is a really powerful data structure, which is not a simple vector, because you got a vector of other vectors. Yes. So you have, so it is not even a tree. It is a graph. It is a mushroom massively. It's not like one node which has 2 nodes and bam, bam, it goes like that. It's a vector of many nodes, and each node can have many nodes, right? So here is a problem in computer science and in mathematics, right? So if you have a data structure, you don't have to, you can talk about it in the forums and you come up with solutions and so on and so forth, right? If you have a data structure, which is a tree, right? You have a node, and that node can have any number of children. In fact, it can have an infinite number of children. So you have a node with an infinite number of children. Right,
Kind of like an irregular matrix.
Yeah, let's say it's an infinite. It's a tree with an infinite number of first level children, right? And then each child itself has one more level of an infinite number of children. And so we want to come up with a scheme in which I put my finger on any of the tree in this graph, in this network. There's only 3 levels. Right, but each level, I can put my finger on any of those trees, even in the middle, and you should have some technique, some strategy, which will just give me a very, very unique number for that. So in other words, you're allowed to start here, right? And then you're not allowed to get lost in here anywhere, right? You got to get to this point where I put my finger and give me a number. And it's got to be some predictable number, right? Some scheme which gives me a number for that, right? So a computational scheme maybe, in which you can actually come up with a number. And if you think about it, it's not a straightforward problem. It's not simple, right? Because this has an infinite number of children. Maybe I put my finger on the second child, right? So you say, okay, 1, okay. But then there's the first child has a lot of descendants. I need to cover them and then get here. But you'll never end up covering the first child, because this first child has an infinite number of children itself. So you got to come up with some strategy that actually works, regardless of where you put your finger, right? So so what I'm saying is that is a massively powerful data structure, for which even today we don't have a lot of algorithms, right? But it could be applied in certain situations in which certain algorithms are useful for it. You can actually use graph algorithms on it and tree algorithms and so on and so forth. You can adapt them, but you can come up with Taylor algorithms for certain structures that use this particular data structure, right? So anyway, so what we've done is a vector and a vector containing other vectors, right? So it doesn't matter if you don't understand this for CS2A, but you will need to do this in CS2B. This is question number 2 of CS2B. You're going to have to do something like this, right? I think. So I'm actually glad that you guys managed to, mock this up. Does this answer all your questions? I think this is a working store. This is a constructor. All right.
Professor, I have a quick question.
Make it public, by the way. Hey, a store. The first one, I mean, the first private in store, make that public and put a comment saying no, above that on line 27. Line 27. Yeah, make that public and put a comment saying public while debugging, right? Public while make that public. Turn the private into a public. Yeah. public, and put a comment on the same line saying public while debugging. Yeah. Hey, Chanya, you had a question?
Yeah, so I'm still a little bit confused about when to use resize and what does resize do.
Okay, so when you ask for a container, a vector, or any of these standard containers that the library provides, it gives you a container of 0 size, meaning this container, it supports everything that you want, right? It has a method that can, that even though you cannot see inside the container, you can ask it, give me the 5th element, and it'll go and get the 5th element for you, and so on, right? So basically you've got the shell of the container. It's got nothing, but it's got everything that it's possible that it can do inside of it, but it's got nothing in it. So that's what you get. When you ask for a vector, that's what you get. You get a container with everything that a vector can do, but the vector has nothing in it. So first thing you do when you get a vector is say, oh, I want a vector, but I want to also resize it to 10, 15 elements, bam. Right now, all of the methods that are attached to the vector have meanings attached to it. Right now, you say, I get me the 5th element, it'll go to the 5th element and get it. It's actually something that belongs to you. Yes, until you resize it, it's size 0. Well, it's a graph or a a tree or a queue, or it's all the same. That's why it's very useful to get to know these just using vector. Vector is simple, and you get to know these methods. But once you get to know these methods with the vector, then it's the same thing. You take the same thing and apply it to a different data structure, exactly the same methods, slightly different, right? So you learn, it's like learning a piece in C major and trying to do the same thing in G, yeah, or something like that. So it's the same sequence of things, same things that you call, right? Only thing you need to know is, well, I can call resize, I can call get the nth element, I can call get to the next element, go to the previous element, and so on and so forth. But it's slightly different. It sounds slightly different, right? If I want to go, that semitone is different here, right? And so you say, well, you know what? If I call size on this data structure, all I need to know is that it's possible, but it's not going to be constant time anymore. If I say go to the previous element in this data structure, it's going to be constant time. But the same operation is available there too. I can get previous element, but I got to be wary not to do previous. So those are the things you learn, right? So when you do CS2B and 2C, you learn that here you know all of these things, right? They're possible, but in 2B you know when not to use certain things, right? Because on a singly linked list, you can obviously have an API call that says, give me the previous element. And many people will do that because it's possible and it's available, right? So they'll do that. But getting the previous element, the predecessor, in a single linked list is a horribly inefficient thing to do, right? You never find professional programmers doing that. So, so those kinds of solutions will work. The bad solutions, right? They'll work, but for small data sets. And it may be enough to get you through the door in some small companies, right? But the right solution is not to use the half-assed way to do this, right? So you need to, and that is why even after you know all the standard interfaces, right? This is the plugging points, right? You know that this tool, I can do all these and these things, but if I use this tool for that job, it's going to be better than this tool, although they can both do the same thing. Right, so that's what we learn. So here we take vector, and I think that is one of the things. That's why I like vector, because vector, by looking at vector and mastering vector, you're actually trading space that you already know. Because you know vectors and arrays and everything. You know square bracket notation, matrices. You learn in mathematics and everything, right? So you know, and using vectors, you're just learning all of the APIs, right? What's possible to do and what can be exposed. And once you know what is possible, then you can take the vector out of the equation, right? You have something else to hang on to. So you hang on to what's possible and then get rid of the vector and swap it in with a tree. Yes? Now you know everything is possible. Oh, but it's slightly, some things are faster, something is slower, right? All you need to know now is, even though everything is possible, something is faster, something is slower, all I need to do is find out why that's faster, why that's slower. Then you know what the difference is between a vector and a tree. Yeah? So, those are the things. It's really fascinating detail, really, really fascinating detail that, and I think that's the mistake, is that people always, try to learn these data structures. And I think they learn the nitty-gritty details of the data structure first, and then look for applications to use it, like, learning, having a lot of nails and looking for things to hammer it on, or something like that, whatever the metaphor is. But I think the better way really is to learn one way of doing things really well, and then using something that you already know, and then keep most of what you know already in place, right? The essential part of it in place, and then swap out things that you can safely swap out, right? Which is the storage part of it. The vector, from a vector to a tree or a linked list and graph and so on, that part can be swapped out, right? And then you once that, because you're confident what you have built with a vector is guaranteed to work. It'll be horribly slow, but it'll work, right? The greatest challenge in CS2B, CS2C, professional programming, right? All of these things happen when people are doing two things at the same time, right? So, and that's what I think that's what Don Knuth meant, right? When he said premature optimization is the root of all evil, I think this is probably what he meant, right? Actually, I don't think he said that. I think he attributed it to Hoare, who said that, right? Or he said that anyway, right? So I think this is what this means. It means that people should, everyone, right? No matter how big of a genius we are, we're actually at our best when we're solving one problem at a time. Right? Even if we have multiple problems, we solve one at a time, we can ace it. And I think what happens is that when we get into a new field or a programmer, right? A new problem, I think there's a temptation, a very, very strong temptation that you need a lot of training to overcome, right? So you can't, and it's a temptation that you have to overcome, I think, right? And it is that we need to both solve the problem, which means I don't even know if it's possible, right? So I'm going to work out the logic and see if it works. But at the same time, I'm also going to solve the speed problem at the same time, right? So in other words, I not only want to play the 40th Symphony, I want to play it at 10x speed, right? So I want to do it all at once, and that never works. And I think this way of doing things is saying that I want to learn to do it first properly, right? So it doesn't matter if it's slow. So I'll learn to do it with vectors, right? And I'll solve this hard problem with vectors, and it's going to be slow, but at least I know the logic is bulletproof and it works. Yeah. Okay. Once you have the logic bulletproof and it works, and it works even, because you're going to try it on small problems where even a vector is sufficiently fast, right? Because you know that a vector is good enough for small problems, but it's not going to scale for large problems. So you make it work with the vectors first in small scale. And then when it's working with vectors, then you say, I want to make it to use the same logic because the logic works. Take the logic to a linked list or a graph, and now you swap out the vector. Now, if you know that something is not wrong, you don't need to look at the logic anymore. You can look at that data structure. Does that make sense? Well, it'll make sense it'll make sense in a few weeks, right? When you're starting to work on the CS2B quests, I think this will all make a lot more sense. Anyway, was this like useful? I mean, we still have time, right? We don't have to take off.
I mean, we might need to finish a constructor for an item. So.
Oh yeah, sure. You want to go ahead and finish it on your own? Do you want me to hang around and finish it?
I mean, we can just create like a random number and I don't know.
Oh yeah, let's do it.
Random name generator.
All right, let's do it. I'll just. But afterwards, you can dissect this program, right? String item and cost. Okay, let's put it in a constructor for item, right? Just put in a constructor public. Yeah, just say under public. You say, and we'll do the constructor right there. Item item, and then let's just say give it two parameters: name and cost and cents. Name string name. Comma, and then in cost and cents. Yeah, in cost. Just say in cost, right? All right. Now indent it in the whole thing. The indented in, and we'll do the inline. Yeah, we'll do it inline. We'll do it inline with an empty body here, right? Indent the item constructor in by 4 spaces. 1 sec. Yeah. Yeah. All right. Now do that thing. Underscore item name on the same line. You can do it on the same line with an empty body. That's fine. Like the thing that we did before, right? Space. Yeah. And space. Yeah. Underscore item underscore name, and then parentheses name. Parentheses name, and then the same with the item cost, and then empty body, empty. Those braces. All right. So now we've got the item out of the way. Right, and they're public right now, so it doesn't really matter. You make it. Oh, you put the comment in front of the to-do, right? Oh, you don't have the public. Yeah.
Do we need an empty curly brace after the cost?
Yes. Thank you, Chanji. right? This is tricky. Too many things at once.
At the end of
Do we
30,
have-
yeah.
Space. No. Okay. Space and then yeah. Okay, good. Put a space there so everybody knows that it's got an empty thing there. Yeah. Space. Okay. All right.
So does it matter that we have 2 declarations of public on 8 and 12?
No,
we
you
did
said
have the
8 and
same
12, line 8 and 12.
8 and 12.
Oh yeah, you can have multiple public sections. That's fine. Or
Okay,
you know,
just curious.
better yet, to do, change the to do to say no, not that. Change that to change to private after debugging is finished. Change to private after debugging is over. Say to do, because that's more. Yeah, make private after debugging. Make private after debugging. Yeah. Okay. So that's a better comment, right? Okay, great. All right, so the item is taken care of. You can get rid of the item explicit default constructor right here, right? Get rid of the default, you know, the non. You get rid of the default constructor. So this doesn't even have a default constructor. You can't get an empty item at all, right? Anytime you ask for an item, it's got to have an item name, right? So actually, you know what? Let's give it a default name. You know, on that line, yeah, string name equals no name. You just put no name, string with a no name, right? And cost equals 0, right? Cost equals 0. Right. So we also have, because that means that you can buy an item called no name with a cost of 0. And the reason we want a default constructor is because when we have a vector of items, it's going to call the default constructor on all of those, right? So it's going to complain otherwise. So in your store, where you have, there you go. When you resize, no, on line 39, when you resize the store, each of those aisles is going to have a 100 item vector. Yes. So, but when each of those vectors is resized, each of those vector has to be filled with the default item, right? But you're not calling each of those item constructors with parameters, so it's got to call the default constructor there, right? So that's why we made a default constructor for item, so that when you expand the vector, automatically it calls the default constructor for each of those items. Yes, does it make sense? Okay, all right. So now we've got the store, and as soon as the store is ready, you got it. Now you can go to main. Well, let's create a store, and then we'll print out the store. We'll just, you know, we can create we just create a main, and oh, is this one file? Oh yeah,
let me move it
we'll create a main right here. Just create a main right here in some sandbox. We'll just create build it as a sandbox here, right? Just do an int main right there, and
Wait, sorry, Professor, I'm kind of lost here. What is the connection between the num items per aisles to the items that we created above?
oh, okay. So can I explain line 39? Line 39, will that answer your question?
Yeah.
Okay, good. All right. So in line 39, what we're doing, it's in a for loop, which means that line 39 is going to get executed for each aisle. Is every step, just tell me if you're on the same step as me, right? Line 39 is going to get executed for each one of the 5 aisles, right? Assuming num aisles is 5, it's going to execute line 39 for 5, 0, 1, 2, 3, 4. Okay, so for each of those aisles, it's going to take the vector of items in that aisle, right? Aisle of 0, that resize to 100. Aisle of 1, resize to 100. So that's what it's doing. So line 39 is happening for 5 aisles. Each aisle is being resized to 100. Does that make sense now? We can put that in a comment, right? Actually, I think he's already got it. Resize each aisle in the store to the number of items per aisle. In the store to the number of items in, per aisle. Number of items per aisle.
I see.
Per aisle. Yeah, get rid of in and then change the numbers to a singular. You'll also save some space, and numbers to a number. I think it's, yeah, you still have a very long line. Line 30, break it up into 2 lines. It'll look better. Yeah, I think that looks better. All right, so now in main, we're going to create a store, right? So it's a capital store space lowercase store, right? So we have a store called store. You know, you can call it store called S-Mart. All right, okay. All right, now we know the store, right? So we can say for yeah, go to the store. Let's create let's create a getter, right? So in the store class, let's create a getter. All right, in the store class, under under public, you say int get numiles. Oh, we made them public, right? So you can actually use a getter and get numiles. Yeah, you can just get open close, and then const, open close, and space const, right? You will get in the habit that getter means bam, like that, right? Yeah. In fact, VS Code can space after const space, and then just say return numiles. No, within braces. That's inline definition, right? And you can do the getter for the other one also. I think it's braces. It's not.
You mean curly braces?
Curly braces. Yeah, no. Braces means curly braces, and then parents means the other one. Yeah, I think it's numiles, right? Num. And then the next line, you do the same thing for the other one also, right? Triple click on the line and paste it again. Change num to yeah. Right, and then I change that to item. What is it? Items per aisle, is it? Items per aisle. Items, you get num items per aisle. It's not total number of items, right? You can, in fact, have a total number of items, but what that's got to do is return the product of all of these things. Yes. All right. So we can, now you can go to your main. You can go to your main and iterate, right? You can say printing out store, right? See out printing out store. On the next line, you can say see out printing out store. Next line, right? And why is it indented in and all? So, yeah. See out, see out. Left shift, printing store contents colon. No, within quotes you can say store contents colon, and end line. No, you can say end line after the colon and end line. Yeah, end line after that. Yeah, okay. Semicolon, right? Now you can put a first for loop. Yeah, for loop. No, for the first for loop for standard. Size t I equals 0. I less than number of aisles. I is less than number of aisles. Get store dot get number of aisles. No, it's a function call, isn't it? We made it a function, isn't it? Get number of aisles. Is everybody okay? Is it following along with this?
Yeah.
All right. On the next line, you want to say you want to have more than one line. Yes, you want to have a brace there. You want to have a body. Yeah. Okay. Right. Now you want to say see out aisle number I plus 1. Aisle number. No. Aisle AISLE. And then let's loop from 1 to 1. Let's loop from 1, not from 0. Right. So because it'll simple. No, don't do that I plus 1 because the precedence rule is confusing. Just say I there. I and then endl. And then you change from I and space next endl. And then let's loop from 1 to less than or equal to. Now, less I equals 1. Yeah, and then less than or equal to. Right. And then get VS Code to clean up that line because the spacing is all funny. Because you don't have spaces on the two sides of the less than or equal to and all, and it looks kind of wonky. And the equals has one space on this side and one space on. Great. Okay. All right. Great. All right. Now you can do a second for loop. And in your second for loop, in your second for loop, you can print 10 items on a line, right? 10 items on a line with the name. And I'll show you how to do it. I have one idea how to do that. Yeah. Again, you can do here. You can say 0 store dot. No. Now what you have to do is store dot. No, store dot. Store dot is good. Store dot. I think it is. Where's your vector? Where's your vector?
I think it's.
Oh, I see. All right, let's define a getter. Let's say for your store, go to your store. Get item. And then it's going to take an aisle number and an item number. As parameters.
Aisle number and item.
Yeah, int item, int aisle number, int item number. Right? And then here, all you need to do is just return right in there, return. Well, what is it? What is it? What's our variable called? Store
items.
Store items, square bracket of aisle number, square bracket item number. Now, what I'd like is, we'll type that in first. Yeah.
Number and
No. You can't do two-dimensional arrays like that and see, right? So, close the square bracket there and open square bracket again. It's a vector, and then that itself is a vector. So you're indexing into the second vector, right? Item number, underscore number, right? And now from the curly brace onwards, take it to the next line. Take that to the next line. Now, semicolon, what we want to do is put a to do there, and say warning, because it's an important to do, right? Warning. This is unchecked axis. Move this out of line and make it checked axis. Unchecked. What does it mean? What is it unchecked? Past tense. What does that comment mean? Can someone tell me that?
You can go out of the limits of the vector.
So I can have a store with 5 aisles and 100 items per aisle, but I can ask this getter to give me the 20th aisle with the 7,000th item on that aisle. Yes. And it'll just faithfully do that for me, although the store is not that big. So it could probably go into the next Safeway, owned by someone else, and get it from there. So that's not possible. That's not allowed. Yes. So it's got to have checked access, which means that this get item, this get item should not return an int anymore. What it returns is a copy of the item. So change the return value on line 31. Return value, right? Return value. No, the return value on the very first, very first.
I moved it here.
No, the very first line on line 31. Very first word on line 31. Int.
Oh, I see.
Yeah, return value of the function. It is not returning an int anymore. It's going to return an item. Yes. But we don't want the person to change the item at this point anyway. So you're going to say const item, right? It's going to return a const item. Instead of int, just say const item. Const space item, right? So it's going to return an item, but it's going to return an item which you can only make a copy of. You can't change the original item. Yes? Everybody okay? Now, later on, we're going to say, well, we want to have a version of that, get item, which also allows me to set the price and set the name. Yeah. So you can say, well, I want to make that getter a const, not const, so I can get it and change it. That's not a good idea, right? Use a setter, right? And a setter can go and change the item. Don't get the item as an L value. I think it's a better idea.
Item number, is this a position in the aisle?
One sec, Mark. You complete the comment. Say period, and say move it outline and make it check. Move outline and move it out of line. Move out of line and make it check. And make and check. Okay, good. So that's enough of a to do, right? To say what we need to do there, because all right. For now, we're going to say. For now, it works, right? So go into your main, you can do it into your main, right? So in your main, you can get the item store dot get what does it say? Store dot size. We need store dot size somewhere. Oh no, the store dot what is it? Get number of items per aisle. Yeah, get number of items per. I plus plus. Oh, J plus plus. Sorry, thank you. JK. All right. So now this has got to be a body here, right? Yeah, good. Thank you. So now you want to say print item equals item lowercase item space lowercase item equals get item store dot get item, right? And then pass it the aisle number and the item number as parameters, comma, I comma j, is it? No, I minus 1 comma j, I minus 1. These are things you got to forget, right? You got to remember. The corner cases, and this corner is different because we changed the comma j. That's aisle number. Yeah, comma, J. Right. Is everybody okay with this so far? We're getting the item. Mark, you had a question. I'll come back to you in a sec, okay? Right. Hopefully the question has vanished. Right. On the next line, and you're going to say, let's put each item within parentheses, right? So you say C out, C out, C out, right? Yeah, and then open, put something within, yeah, let's use parentheses, right? Put parentheses within quotes, put in parentheses within quotes, right? And then on the, yeah, after that, left shift. I'm just formatting it, right? You can always format it your own way. Oh yeah, to the end of the line, left shift again. No, left shift. Yeah, and let's say item name. I think you're going to say item dot get name, is it? Or is it everything is public, is it? Item dot. Hit item dot. Does it get item? All right, it's public, right? We don't have a getter. Everything.
We don't have a getter of the items.
Yeah, it's all public. It's all public. So I said item dot item name.
So,
right? And then left shift a comma. No, you got to left shift a comma, and then the cost also. Left shift a comma, and then the cost divided by 100, which should be cast to an integer, so we get the dollar part of it, right? In fact, you can say comma and then put a dollar after the comma, right? Inside the quotes, you put a dollar after the comma. Put inside the quotes, put the dollar, right? There you go, right? Yeah, comma. Yeah, that's right. Yeah, and then a comma after that, because everything is going to happen in integer space. Yes, that's fine, right? And then you say. Yeah, item cost %100. Item cost %100. Item cost. Cost %100. And you can put that in, put the plus, divide by 100, % has 100, all that in braces too, so that it's clear that, we're having operated. And we'll have to split it into multiple lines too, right? Take the dollar, everything from the dollar, put it on the next line. Oh yeah, it'll look better, I think. Yeah. No, you can't do handle yet. Yeah, hang on. Yeah, put that on the next line. Yeah, it's all getting too long. Put it on the next line. Put it on the next line. Start. Go get the dollar on the next line.
Oh, I see.
Yeah, put the dollar on the next line. Well, let me see. The dollar. Yeah, I think no. We need to close before the end all. You need to close the parentheses, right? That within quotes. Within quotes, you have the parentheses, right?
Which quotes?
At the end, get rid of the end all, standard end all. All right, space there. Cleaned a bit more so that, because VS Code is just putting it all right there.
I cleaned it. Here. Okay.
All right, now we can see clearly. Something is funky here. You broke up the string. That's why it broke it up, right? You got the string, the quote, and the comma on the previous line. That's why VS Code got confused.
Yeah. I just wanted to break it because it was too long.
No, you can still break it. But you can break it inside of a string. You got to break it after the operator, not inside of the string.
Okay, so here.
Yeah, but yeah, that's correct. But I would keep the dollar together with the cost rather than dollar together with the name.
Okay. So
you can break it before the.
No, but now you broke up the cost. You broke up the cost.
Yeah.
Keep the cost together. Keep the cost and the dollar together.
So
yeah, that looks good. Yeah.
Okay. All right. That's good. And I think yeah. All right. Now close the first the quote. Yeah, on the next line. Yeah, on the next line. No, not the semicolon. Put it on the next line. Don't put semicolon on the next line. You still haven't closed the visually. Now we close everything syntactically is okay. We want to close it visually. We want to play this out. The output of the C out. We have to do that in our head, right? So that thing that you have in the output, in the output you have that hasn't been closed, right? Because the output will look clunky, right? So on the next line. Yeah, on the next line. Not there. On the next 62. Line. Yeah. All right. Now left shift.
Mm-hmm.
Right now, close that. Put that closing quote within quotes. Closing parentheses within quotes. Closing parentheses within quotes. All right. Okay. Now we want to do one more thing. Okay. Now put a semicolon there. Right. Now we want to do one more thing. Because an aisle can have 100 items, and each item is basically something within parentheses. We don't have a big ass line of 100 parentheses thing, right? So what we want to do is do something visually appealing. Again, look at it, right? So we're looking at it from a user's point of view. Well, what happens when it runs, right? So we want to break up the output also, not just for the programmer, for the user who runs it, we want to break up the output. So we want to say, when we've printed 5 items, well, let's go on to the next line. Yeah. So in order to do that and make it all visually appealing, what we'll do is also, when we print the item, we'll print a tab before the first item, right? So what we want to do, we will do all that, right? So before all our items, one sec, Turkey, before the parentheses on line 60, insert a /t, /t, right? That means a tab. Every aisle, it's going to say aisle number 0, and then the items in the aisle is going to be tabbed in. Everybody okay with that? Okay, good.
Yeah.
Now, what we're going to do is on the next line, inside of the for loop, we're going to say, after 5 items, instead of a space, we're going to print a new line. If it's a 5th item, instead of a space, we're going to print a new line. So what we're going to do is say cout, right? And left shift, we're going to say, unless it is a 5th item, we want to print a space because we just want to go on to the space on the next item, right? So we want to say, what is it? J for the counter. So 5th item, which means 0, 1, 2, 3, 4, 5, 6, 7. So we want to, every 5th item, you want to have a space. So what's a way to get, what's a way to get from, so 0, 1, 2, 3. So if you add +1, it shouldn't be divisible by 4. Yes? If you add +1 and it's divisible by 4, that means you're on the 5th item. Okay, so of each line. So we want to say on the cout line, we want to have a little expression right there, right? Within parentheses. Yeah, right, good. And while we're there, put on line 61, turn those divide and percentage expressions also within parentheses so that it's all clear, right? So that it's, yeah, put that within parentheses. All right, even the other one. Yeah, even the other one, item cost, right? Yeah, put that in parentheses. Yeah, parentheses. Okay, good. All right. So now, in here, inside parentheses, what we're going to do is say J +1 within parentheses again. J +1. Yeah. %4. Double equals 0. Question mark. Right. Now space. Yeah, thank you. Yeah, that looks better. Right? Now, if it is equal to 0, what we want to do is, oh, it's a 5th item, right? So we want to print a blank line there, say new line, /n. Right? If it is not equal to 0, you just want a space to make space for the next item that's going to come on to the right. Yes? Okay, all right, let's do that. Right? Now, eventually, when you have this working, what you can do is take exactly this logic from main and move it into a 2-string function for your store. Yes? And use 2-string can build this in a string and return it instead of outputting it to cout. So that's how you do everything, right? So everything you just test it out in main and move it, test it out in main and move it, and you get your whole project done, right? So and then I would say after you printed an entire line, /n, yeah, that's fine. Oh, after you print out the whole store, what happens if you end up in the middle of a line? You won't have a new line there, right? So after the last for loop, after the outer for loop, just print a new line. Print a new line right there. Yeah. All right. Now I think you should be able to run the program. If I'm not mistaken, it should run. It should compile and run and print your store also, right? Unless there's an error.
I think we didn't declare a name, so we have items with no string name.
No, it should still get a default name.
Oh,
no,
we have a no name. Yeah.
Yeah. No. What is the error? I don't see the error.
Let me run it again.
No, what's the first one? What's the first error? Oh, I see. Oh, it's just syntax error. Line 12 or 16. Go to line 12 or 16. It's just missing something. Yeah.
Maybe.
Yeah, semicolon. Compile again. Run. No, compile again. Oh, still have an error.
Yeah.
Before name.
Oh,
Right?
STD.
Yeah.
Let me just double check if we have any other strings. I think that's the only string.
That's the one. What happened? You still have errors?
Let me clear it so it can be clear.
Yeah.
Yeah.
Let's go to the first one. But, oh, it says standard vector.
23.
Just use the namespace standard at the top right now because it's a CPP file anyway. It's not a header file. Just use the namespace. For now, because we're ended class and all.
Remind me of the name.
Using namespace, using space namespace standard, right? We just use the whole thing right now. std, semicolon and enter, right? Okay, that should fix the vector and string everywhere. All right, now return num semicolon missing, semicolon after the return statements.
Where is the return?
In the getters, the two getters, both your getters. Up on the previous line also, that line and the previous line. Yeah. All right, and I think that is it. That's it. Expected store doesn't have semicolon at the end of input. Oh, maybe you can. Oh, all right, okay. But no. Just cut it from there. Cut the whole line from there. Cut the whole line from there onwards. Yeah, cut it. Semicolon there and close it. Now go back to the place where you have the declaration. Right there. Put the paste it back on at the end of line 40. No, not at the end of line 42. At the end 40. Of line 42. Yeah, okay. That's where you chain. You have to have the colon and everything, right? And then
add the semicolon.
No semicolon, but you can get the. Yeah, I think that's fine. Put a space before the colon. Because it's clear. All right. So I think that's how you chain forward, right? That is how you chain. Oh, it's stuck in an infinite loop? No, it's not. Yeah, okay. I think it ran. Yes, it ran. Can you increase the size of the console?
Yeah.
Number 1. Why is it not printing a space before line idle number 2? So 100 items. So for 20 after 20 lines, you should have a space.
After which
so you can 5 aisles like that, yes?
1, 2, 3, 4. So let's just make it 5 instead, right?
No, it's already set to 5.
Oh.
But we should not be using 4 there. We should really be using get num items per aisle or whatever that is. Number of aisles. You got to get number. Well, you can do that all in your own time, right? So you can basically say get number of aisles and do all the protection and everything. We have a lot of 2 items anyway, yes? So this is one way of doing this. Yeah, we didn't do any pointers today. Is that okay though? But we did get something done, I think, which probably hopefully nailed in some of the earlier concepts better. Did it help, you think, today? Yeah, okay. Can you follow the videos that we have on from previous quarters on about pointers? There's a whole bunch of them on pointers. And I think they're pretty self-explanatory. And some of you guys were coding also in previous classes on pointers. So you can actually have you can see how that went. You can imagine yourself in the shoes of the person who was coding. Is that okay, you guys? Yeah, is that yeah? Was that a useful last class?
Yeah, the one-liners were great.
Thank you. So I think we covered a lot of important concepts in this class, and I think we also talked about some very important things, not just for CS2A in particular, but 2B, 2C, and also C++ in general, and what makes for a good programmer, and how to overcome these programming mental blocks. Times when you get stuck, and looked at possible reasons why many people give up projects after they start, right? So I think we have to be prepared right at the beginning when you start the project, saying this is sunk cost, right? I'm going to do this project anyway. Even though after 2 months of learning Unreal, I might come out, right? I don't know any Unreal today. And after 2 months, I come out having done nothing in Unreal and basically saying, I'm not going to do it anymore, right? I've given up. That's fine, because I've already given up now. And these 2 months I'm doing is basically just playing around and saying, if I'm going to give up, let me find out what I'm going to give up, right? That's what you're doing. So you're going to give up at the end of 2 months, but during these 2 months, you're going to find out what you're going to give up, right? And then at the end of 2 months, you say, well, you know what, maybe it's not worth giving up. I'm going to hang on to all of that anyway, right? So now make your mental decision that you're going to give up. And then I think you'll find it a whole lot easier to just scream through it, right? Because everything will be piece of cake after that. Hopefully this helped. And just be aware that I'm happy to do a class next week if you want. And even if you want a class in summer or off cycle, right? Even next week or week 12 or later, even during the spring break or whatever break that is, right? if you want a class, even to do with something else, extending this into a game development environment, Unreal, or cloud using Amazon or Google, right? Azure. We can try all those things. We can play around, right? We can try and port this into Python or JavaScript and see what changes we need to make that go from here to Java, right? So these are things we need to do to tweak it and so on. And in fact, I don't have to drive those two, right? Someone who already knows that can try and take this and turn it into that. And then, if they're stuck, or you can ask, hey, do you know how to do this? And I can think back and say, hey, from my knowledge of Python, what I remember, we can try this, right? Or we can Google together and find out and things like that. And I think it'll be fun, right? So we can do that. And obviously there are a bunch of contests, right? There's a bunch of contests I'm running in CS2C mainly for $1. So I'm paying CS2C students some, money if they crack some programming puzzles, just to keep it fun. And it's not just open to CS2C students, right? So you can also, since you know C++ now, and most of these challenges you can solve just using arrays. You don't need sophisticated data structures. So you can take your crack and hand at those. If you have time, you can do that too. All right. So thank you all so much for your patience and through the entire quarter, right? And most of you have been attending all the lectures, even though the lectures are optional. You're sticking around, past the end of the class and all. And thanks very much. I hope to run into you all again in the future. All right. So I'm available if you need help. Okay. So just feel free to reach out and make use of the STEM Center. And, those people also look forward to helping you. All right. Thanks very much for your time and understanding. All right. Best of luck. Everything you do.
Bye.
Bye.
All right.